Good morning. And it's Wednesday, so we're halfway through the week. Looks like today, or where we left off, was we were just in the beginning of creating the grid. And we were figuring out what was going to go into the points and what it was going to look like. Good morning, Miguel. And so we had decided on a vector of vectors. So we'll have just like a vector in general, and then each vector inside of that will be the x row, and then as we continue on, the y's would essentially be the other vectors going down. And so this is basically where it's holding points right now, but I don't think this is correct because this is just a grid essentially without anything else. But we decided that we're going to have this structure that has coordinates on it, or it's going to be a structure of cells. And each cell is going to have to know where it is on the board, like which one it is, and is also going to have to like no other information, like whether or not it has a piece on it or something else. And I was thinking for the piece that this should be an enum because it's going to be one or something else. Like for example, you can't be on the same piece, the same square as a bullet. You're automatically hit if you're on that. So I'm kind of thinking of just sort of going all in on game board style rules, which is like this is going to be turn-based, and the bots are playing the game as in like I'm going to move to this square now, and I'm going to fire in this sort of board direction. So I'm going to fire like to the right, and it just follows those squares all the way down. And I think that will work. Because then I could say, okay, this cell has the following thing on it. It has like the bullet token on it. And the only way to tell where the bullet is headed from a player's perspective is to watch it over time. And it's like, oh, it's moving in this continuous direction. And then the piece, like, then there's the bots, and you can't be on the same tile as a bot, so you just lose your turn if you attempt to move into it, unless of course you have like a push. Like then there could be like a push object that you can get, which will allow you to push other bots when you move into them. Unless they also have that, then you just sort of butt up against each other. I think that would be interesting. Basically, it's going to be like a board game that can't actually be a board game, because that would be boring if it was in real life. This is a board game that bots play. But that being said, our sort of initial vector here is wrong. And I was thinking about yesterday how the piece here, because it's an enum, I guess like the question is, or I guess like there's going to be a cell structure and then a piece enum. For architecture of this game, it feels like it might be better for me to switch to a more folder-based system, and maybe not like switch everything at once, but just start doing folders now and refactoring as I run into this. So for example, the cell is only going to be used by the game grid, and you're going to get to the cell through the game grid. So I'm kind of thinking that I want to create, oh, nope, not that. I kind of want to create a new folder called game grid. Rename game grid to oh, I can't do that yet. Move game grid into the folder, then rename it to librs, and I believe now in librs, when I do this mod game grid, it actually will still be able to find it inside of here. And now in GameGrid, I can now create a cell.rs. And inside of this lib, I can mod cell. And I believe what that does is it looks inside of this folder. Yeah, source GameGrid cell.rs. So perfect. So I think this is how I want to do it from now on, because cell actually is related to the GameGrid. Now we have this test, and I don't really want to run it right now because we realize that we need to have a vector of these cells, and this isn't helpful. So we're going to keep the mods in, and we can keep the uses. It'll probably yell at us for not properly actually using them. But if I go into cell, we can now do our tests in here. So let's, I guess let's just begin. So we'll have our configure test. We'll have our first test, and we'll just do this cell new. Oh, the name might conflict because Rust already has a cell structure. Oh, it does. Let's go take a look at that cell structure. Shareable mutable containers. Okay, so not kind of what I want. Good morning, Fletcher. That's on the edge, but I'll take it this time. All right, so we don't want to call it cell. Let's call it maybe game grid cell. Maybe like grid square. Like I'm not sure what the right word the word for it is. Maybe grid cell. That might be better. So, or I could just call it game grid cell for maximum wordiness. Game grid cell new. And so in here, okay, so we want to create a brand new cell, and what we want to see stored in it is going to be the coordinates of where it is, which the game grid will probably tell it. Could always, yeah, absolutely. Outside neighbor, I can always change it later. And the piece, the enum for that. I do have one question that maybe you all can help out with. Should enums like this piece, should that be a separate file in here? I mean, it's only going to be used by essentially the cell. At least that's what I'm expecting it to be used by. So would that be best as an external, like its own file? Or would it be best to go into the game grid cell file? I'm not completely sure. I'm not completely sure which way I should do that. And I don't really feel like it's best to create like an enums file like that's shared by everything where all the enums are created. That feels a little bit too, it feels like it's going to lose a lot of contextuality if I do that. All right, so if we know where we're going to have it's probably going to be a point, right? Where is it? This one. The coordinates is probably going to be a point because it's an XY location. But that point, we wanted it to be, okay, so this is going to be the other interesting thing. We wanted the point to be integers as opposed to floats. So there's this here. And so before going on here, now let's go take a look at point, because we want points. We want this to not just hold F32s. If possible, we want to have this hold I32s. And so that's where this gets interesting. Because essentially, if I remember, is it like this, where I want this to be type, and these can all be the same types. So your RLS is not yelling at me. Okay, oh, game grid cannot. File not found for module game grid. Name the file either gamegrid.rs or gamegrid/modrs. Okay, so it's not lib. I was wrong with that. It is modrs. That should make this go away. Well, okay. It's there now, so maybe restart the RLS. Okay, there we go. So we got you. Then in mod RS, we have mod cell. Oh, right, and you don't exist yet, so I'm gonna go ahead and just delete you. You don't have any tests in you, so we should go ahead and comment you out. Okay, and bot, now it's wrong number of type arguments, expected 1, found 0. Type arguments. Oh, for point, because this is going to be a point like F32 is what that's going to want, doesn't it? Expected 1 of... Oh no, okay, so we got that. Then down here, move bot, distance point. Good morning, stacking. So basically it looks like what we're doing now is going through and telling the points what type is going to be in it for the type system, since point is now going to be a little bit more generic than F32. Binary assignment operator cannot be assigned to type point F32. Okay, so we need to add in that on point here. Let's see, implement point, wrong number of type arguments. Right, so this is going to be now generic type. You're going to be our 2 generic types. And you're returning a generic type. All right, I did that wrong, I think. Can I find type T in this scope? Well, of course not. No, I don't want to use enum T. Okay, let's go remind ourselves how to do generic types properly. So Rust lang generic type. So it's like this struct that implement T. That, so I just didn't do all the T's. So it's here too. Yes, you are correct, Miguel. Miguel, yes. That made it work. This is the one thing that I sort of have trouble with the generic type system, is that you just have to spread these around everywhere. It's unintuitive to me that you have to put it here and here. Okay, so for the next one, get GG easy 0.2. Now here's the problem: is it doesn't know what type it is, so it has to convert over. So this is where this will not work unless we verify that this is going to be a type, a number type. So we need the where clause. I think, is that in the function or in the implement? I can never remember. It's this doesn't have the where. Do we have the rest by example book? No, of course not. I think the book had it too. Oh, these are all just GitHub. Okay, so let's say wrestling generic types, where implement. Okay, so this is the second edition. That might be helpful. I feel sad that it's not, that it just doesn't get it right properly. Abstract, yeah, this is, to me it feels a little bit sad that it's not going. Okay, so we'll go to the current book. Wait, did it drop me into the beginning? All right, let's go find generic types. So I'm looking for the where, so I could basically say like only apply this where it's like a number of some kind, and then we can go take a look at what number types share. Let's see. I don't see any wheres yet. Oh, this is lovely. The code doesn't compile. This might be a good thing to look into later. I did not watch that. I heard something about it, but I'm not fully aware of what happened there. So we'll go to another page so I can keep that one. Oh, this is now we're on trades. Default. Okay, so this is not necessarily helpful because that's that we're on traits instead of types. All right, I'll go back to Google. And let's do this will be Rust lang generic type where struct implement. Let's see if we can Rust by example implementation. No wheres in here. I mean, I am remembering that it's where is correct, right? Oh, implementation of generic val where we explicitly specify type parameters. So we could do that, but I want one implementation for both of the types, which I believe it's something like implement, or rather if I come back here, I believe it's something like implement this point, and then before the opening, it's something like where T is, and then like some trait that I believe that's shared across both. What would it be like? Standard ops. Yeah, for example, add. We want numbers that have add. Where T has trait. Well, and so I believe that both okay, so it's like this then. This would work. Now, what are you upset about? Match. Oh, right. So now I need to set. Well, maybe. Now I need to reassign because it can only be one. It's something that has add. That means it should be able to be cast as an F32. Oh, you didn't like that. Okay. Oh, so we can't use AF as with generics. Okay, fine. There is the from trait that I could use, but isn't maybe like, does parse only come from strings? Or do I want to do something like if I don't do self X, could I do, I guess like a standard F32. There's no from for that. All right, let's keep on looking. If I want to convert from a generic type into a specific type, so Rust lang convert generic type specific type. I keep on. I may have to just change my default to. I may have to change my default search engine to Google because I like searching in the top bar. Hey, give me Rust. All right, let's take this search and go back to Google. You're not sure, but there might be another trait for being able to convert to F32. All right, well that might casting to a generic type. I want to cast from a generic type. Wrestling, I guess, cast from generic type. And also, good morning, Danny. Converting generic T back to struct. I don't want to make it back to structure. Right, so why is my Firefox don't... I thought they did, but maybe it's not on this this OS. The exact error. So the exact error is I'm taking in this in self. I have X and Y, which are generic types, and in my mind, I'm thinking of these types as going to be, and I could probably do the where here too, right? where t is going to be something with, if I'm using it twice, I might as well bring this out like that. So cut and use that. I'm thinking about add because add is something that numbers should have in common. Like integers and floats should both have these. Oh, it updates to the repo. So I need to run the, I need to go in and run apt update. I can do that. And what that means is, so where t is add. So then I come into here and I want to convert. So G.2 only takes F32s. So now I needed to convert from some kind of number to definitely a single type of number. So if we just comment that out so we don't get the error. If we want to first do something like let the x, which is an F32, equal self.x, this won't work. Also, I guess I'll just give this like a 1.0 and a 1.0 to make the errors go away. Add isn't necessarily a number. It could be anything like a string or a struct. Oh, really? Okay, never mind. Then add is not correct. Let's look through some more things. I thought most things in operations would be that. So what else can I find in here? Divide. Divide is something only numbers can do, right? So if I want to this, I can do divide. And now we're saying, okay, expected type F32, found type T. Can use the types you want to allow instead of the type constraint. So I'm not sure how to do that with, can I use generics? I guess like would this even be generics where I can say like, I want this to be one or the other type? So I want this to be an integer type, or let's say I want it to be I32 or F32. And really it can be a U32 because I'm never going to go negative. But I figured like floats can go negative, so to keep the same general number like closer together, I32 is probably easier. But because that's not a trait, like I guess this is where my knowledge of this is not sure about. Oh, so like basically a double, so where I can have in this struct, instead of this where clause here, I would do pub x, and this would be like an F32 or I32, and make it sort of like a union type. Yeah, so it doesn't like this, expected a comma, but found this pipe. So definitely doesn't like that. So let's see. Oh, standard convert into. A conversion that consumes self. the reciprocal of from, if the conversion can fail, use try into. Using into trait. Also, good morning, hungry spirits. Is that into? Here is into. Yeah, we could try this into trait. This trait must not fail. If the conversion can fail, use try into. Well, try into. Yeah, okay. We could take a look at that. This is a nightly only experimental API. So I'm not using nightly. That's going to be a problem. Try from maybe? Nope, that's nightly only. How about from? Simple and safe type conversions into self is the reciprocal of intro. So how would I use this? Okay, so string, well, okay. That's not necessarily helpful. I guess there's the standard num. I'm curious what that is. Would that allow me to convert? Because could I do num parse int or parse f32? Okay, I kind of want to see what happens if I do this. Everybody back into the pool here. So that should make everything better here. Then down here where we have division is allowed as, so where only the types are division. We want new, so we know that you can only be this thing. Okay, so GG. So for the get GGEZ 0.2, we want let x f32 equals, and this is, I think, what was it? Standard number, additional functionality for numerics. Oh, these are, so errors, test number. Provides intentionally wrapped arithmetic on type T. Operations like plus and U32 values is intended to never overflow. Okay, so I don't know if that's, this is helpful though. I think the try into might be good, except it's nightly, and I don't want to do that. I guess there's the from. Is from just a trait? It is. So I would still need to implement that. String implementer from. I'm gonna have to have implement for each type that I want to allow. That seems, that feels like it just undoes the I guess that feels like it undoes the generics of it. So if I was to do that, implement, I think what this was like F32 for point T. Is that how it works? Can I find type T in a scope, or is it like T that? I saw it somewhere where you could basically say like, I want it to be implemented for this specific thing. Oh, okay. I can only do it with a trait. Let's go take a look at the trait for F32. So street F32. So for this, we can go take a look at the types that it has, the traits that it has. It has a from U8. From U8, from I8, I16. Looks like they never implemented a from I32. They have a divide, add. It's from implement div. Might be a trait on I32 instead. Let's go take a look at I32 now. I want to I32. Okay, so there's all these froms. Remember assign, divide, assign. Shrink assign. Oh, there's tons of traits on an I32. Try from U32, no F. Divide, bit XOR. Cast into and not F32. That's sad. Blanket implementation. So if I do try into, oh, that's nightly only. I thought we just looked at F32, but we can go back there in a second. So from try into is also going to be nightly. Into implement T into T, you from. Wait, so if into T, so into you for T, where you from T, to you from self. Can I do into? I want to use the, what is it, the play. So let's try let f equals like 5.0. And we want to let I equals like 6. if I want to create a new, so let's say let a equals, and this is going to be the I converted into an f. So this would be I dot, and what did we see here? Into. Is it capital? Implement into 40 where, yeah, function into, and then we hand it. Huh. Implement tu into u for t where u from, and then we're giving these types. Function into takes in self and returns a completely different type. How does it know what type that I want to go? It's too bad there's no. Yeah, that's not the same. I can implement both or none. I'm kind of wondering, okay, so if I do let a equals I into I dot into, it doesn't seem to take anything. So if I do this, do I have to tell a that it's type F32? And then can we print line a? Error, compile line trait bound F32 standard convert from is not satisfied. The trait standard convert from is not implemented for F32. Okay. So it might be okay in the I, but not in the F. Is that what I'm seeing? If I change this around and I do A is the F, do we get the same error? That becomes a 5. And so if I change this to like a 5.9, that didn't work. It didn't error. It didn't error. It just let me. Oh wait, nope. Never mind. That's fine. I32. Now, okay, so it doesn't have it on either of those. So that's the problem. And we found out that we can't implement traits on existing structures or types by ourselves. So that's not exactly helpful. F32 into I32 shouldn't exist anyways. Well, that was the hope that I could do all the calculations in integers and then at the last second convert them back to floats. But if they're generics, that won't really help. So it sounds to me like then we're going to need to come into here with generic data types. And I think there was something we found. I thought I saw while we were looking here, implement point F32 here, where it's like, okay, implement this for F32 types. And this is where point is type T. This is like literally the thing that we have. Just round. We'll let it round up or down. Yeah, it'll be fine. Okay, so we're gonna have to do this. But even if we know what it is, we're gonna run into problems when we eventually do want to convert into F32, because that's what GGEZ, that's what the game engine needs. And at this point in time, if it's not, I mean, does this mean that I just have to do all the math in floats and like I can't use any integers? F64 has a from I32. You need to do an implement for each type you want to allow your points. But the problem is I want this get GGEZ point 2. I'm gonna need this on both integer. I need to pass it a floating type. And so if I have an integer, I need to then convert it right before here to a float, so that way I can pass GGEZ point 2 a float. And I think that's the problem, is they want a float. If I'm going to have an integer, I need to convert from an integer to a float. And they need an F32, so I can't use an F64 either. Well, and so that's the idea, is that I want to be able to say, find a trait that only that is shared between them. But I'm not sure those exist. And can I? That'd be kind of funny. Could I like almost kind of force the issue by creating traits? What is it? Trait like my number. Can I do like an empty trait like this? And then I want to implement my number for I32. Will this work, or will it just be really upset at me? If I don't have any of you, and we just do a print line hello, and do that. Expected one of BAM. Oh, implement. Okay. Okay. That. So if I also do implement my number for F32. So these are going to be empty traits, and I'm only putting on these specific numbers so that way I can say there is no way that anything else can have this. So if I do a struct if I go this route, I'm going to have to write an implement for each type you want to convert to F32. Yes, I would. And of course, like the problem being that the future is hard to predict can make that a little bit more difficult. Right now, I'm thinking only I and F, integers and floats. But of course, like there's a possibility that this will blow up in my face and just be a horrible, horrible disaster later on. But if I do this struct where it's like, okay, struct, is it just point T right there. So I'll do 2 impls on your point type for I32 and F32. Okay, so if I have like my struct point, and this is type T, and I have like an x, which is t, and a y, which is t. And then that means we're going to implement, and I think what this was is I can do an i32 implement point type t. Is that, am I getting this completely wrong? Let's see, where was it that we found this? So we saw this implement point f32, but okay, so if we do that, implement f32, it wouldn't be point t, it'd be point f32. And then we'd have some conversion here. So on f32s, we want to essentially have a function convert, and this is going to take in a reference to self and going to return an i32. So would I be able to say, like, let's say I take an x and we're going to return the x for this. Would that be an as? Like, we didn't see a from, so could I do essentially self.x as i32? Will you run? No. The type parameter i32 is not constrained by the impl trait, self-type, or predicates. Unconstrained. So I was hoping that this would be, oh wait, I wanted f32. Non-primitive cast, f32 is i32. And as expression can only be used to convert between primitive types. Consider using the from trait. Would that work? Let's go take a look. Feels like this one is almost, oh no, it's the same size. Allow, okay, so we have two different points. Point is a generics t. Implement generic t for point. So you're doing that. Implement point f32 from GGZ, so function GGZ self, print line f32 stuff. Well, I still need to convert. Then do a second implement point i32. The problem is when I need to draw, I'm going to hand the board, or rather the main library is going to have the board. So if we come back to here, and in draw, we have this grid, and so currently it's drawing the grid here. I guess, am I going to be able to do something? Is going to need to convert over to f32 eventually to hand to GGEZ in order to properly draw and like do the other math calculations. Because I do want to draw the actual grid out to the screen. Like I want to actually draw it to the screen to make sure that it's working. So if I have them as integers initially, I need them just add a .0 to it essentially to make it a float, and then put it in there. So it's great that I can implement point i32 and implement point F32, but in the implement point I32, I still need to convert to a GGEZ point, which is going to be an F32, which will need to convert the I's to F's. Which has like, we run into the exact same like converting problem. At least that's what I'm feeling. And so this is where I think my lack of knowledge of Rust is coming back to hit me, because I'm sure there's an easy way to do it that I am not. After you force it to be an I32, does as work. So that's what I was trying here. Is this is forced to be an F32, and I'm trying to convert it into an I32 with as. And I can do the exact same thing where I just say implement I32 to take and point I32, and then we'll have function convert, we'll take in a reference to self, and we'll turn F32. Then we'll just say self.x as F32. What if you used an I16 instead? So if I run this, you're still upset because both these cannot work. But what you're suggesting is that I used an I16 here. I16. This becomes an I16. I16. The type parameter I16 is not constrained by the impl trait, self-type, or predicates. Did I not implement this properly? So implement my number for I16. Oh, I guess the other thing is I want to, well, it doesn't matter. We're not really using these. So like those could be commented out. So we have our generic points, implement F32, convert into an I16, so self-x as I16, or implement I16, point I16, convert into an F32. So if I run U, duplicate definitions for convert. Yeah, that's kind of the point, isn't it? This one is for F32s and this one's for I16s. Get rid of the after the impulse. Okay, let's try this. Okay, so we have hello. So it compiled. That's a good sign. So implement point F32 and then I16. So if I want to convert over, so I can do a print line, and we'll just say, I guess we have to create a new point entire system. So we'll do let F32 point equals point, and we'll have something like 1.0 and 2.0. And we now want to let my num1, like let's just do num of type I16 and set that equals to F32 point dot convert, like that. And then we want to now just print line the num. If we run this, okay, lots of errors. Expected identifier found 1.0. Where? Oh, yep, I forgot. X, Y. I'm so used to using the new. Okay. That seemed to work. If I do this as like a 1.3, it turned it into a 1. All right, that seems to work. Yeah, I'm just returning a num because I figured this was this is good enough right now to be able to like force the point and make sure that I can do the casts correctly, and I think this will work. So you need to use half the size of the integers. Now, okay, so from what I understand, and correct me if I'm wrong, the reason why this will work is because F32s end up spending some of the space in memory on the decimal points, and so therefore they can't go, the number to the left of the decimal point can't go as high or as low. And so if I was to convert an integer into a float, like an I32 into an F32, it would be out of bounds. And so if I go half the number for the I16 instead of I32, it's guaranteed to be able to fit within the potential memory space. Is that correct? F32 has a mantissa that is less than 32 for the significant figures, and I32 uses 31 bits for the significant figures. Okay, that makes sense. Okay, so this is what we're going to work on next time. But I will not be able to stream tomorrow morning because I have some appointments that I have to get to before work during my normal stream time. So unfortunately, I'll be skipping that. I will send a tweet out tonight saying that, but also just for those of you who are here, I won't be able to make it. I know, but it's 7:34. I've got to go catch the bus. So sorry everybody for leaving, but we got this all figured out, and we can work on this and get it up and running next time. All right. With that, I shall see you all next time, which I believe is going to be Friday. Yeah, this is a super good. This is helping me learn about how to do cool things with Rust. Super important, super good. And thank you, everybody, and see you next time. Have a great rest of your day, and a great tomorrow too.